In this video, we're going to go over the KutaSoftware Infinite Calculus free worksheet, Instantaneous Rates of Change. An instantaneous rate of change is similar to that of the average rate of change. Remember, the average rate of change was the slope of the secant line. An instantaneous rate of change is the limit of f of x minus f of a all over x minus a as x approaches a. This is known as the slope of the tangent line. So finding the limit of the slope of the secant line as x approaches a will give us the slope of the tangent line. So let's jump into number 1. Our directions for 1 and 2 say for each problem we're going to find the average rate of change of the function over the given interval, and we're also going to find the instantaneous rate of change at the leftmost value of the given interval. So we're finding that tangent line slope at a. So let's look at number 1. In number 1, a, the start of our interval is 1, and x, the end of our interval, is 3/2. So finding the slope of the secant line, which is the average rate of change, that's going to be f of x minus f of a all over x minus a. So for this, I'm going to start by finding f of x. F of x is going to be f of 3/2, which equals 2 times 3/2 squared minus 2. That's going to be 2 times 3 squared is 9 over 2 squared is 4, so 9 over 4 minus 2, which 2 times 9 over 4 will simplify to 9/2, so we'll have 9/2 minus 2. However, as opposed to subtracting 2, I'm going to subtract 2 in terms of 2, so subtracting 4/2. That will give me a positive 5/2 as f of x. Now I'll calculate f of a. F of a is f of 1, and that's 2 times 1 squared minus 2, which equals 2 times 1 minus 2, which is 2 minus 2, which gives us 0. So f of a is equal to 0. Now that I have f of x, f of a, and I know what x and a are, I can calculate that slope of the secant line, which again is my average rate of change. So m of the secant line equals f of x, which we calculated to be 5/2, and I'll be subtracting f of a, which is 0, and that's going to be all over x minus a, which is 3/2 minus 1. 5/2 minus 0 is 5/2, and 3/2 minus 1 is a positive 1/2. Now if I have 5/2 divided by 1/2, that's the same as having 5/2 and multiplying by the reciprocal of that denominator, which is 2 over 1, which will give me a positive 5. So my average rate of change is equal to 5. Now I have to find the instantaneous or instant rate of change. But before I do that, I'll go ahead and graph that secant line so you can see that slope. So a, f of a, is 1, 0, and x, f of x, is 3/2, 5/2. So there is my secant line. Now my next step is to find the slope of my tangent line, which is my instantaneous rate of change. And remember, the slope of the tangent line is the limit as x approaches a of f of x minus f of a all over x minus a. So this is going to be the limit as x approaches a. So we're going to leave x in terms of the variable because we're looking at it at that point a, which is 1. So the limit as x approaches 1 of f of x, which is 2x squared minus 2, and we're subtracting f of a, which we calculated f of 1 to be 0, so minus 0 and that's all over x minus a, which a is a positive 1. So we'll have the limit as x approaches 1 of 2x squared minus 2 all over x minus 1. Now we can't solve the limit of this because plugging 1 into the denominator will give us 0, and we cannot divide by 0. But let's factor and find an equivalent limit. Factoring the numerator, 2x squared minus 2, I'll pull out a 2 and have x squared minus 1, and that's all over x minus 1. So now, factoring, what multiplies to give me negative 1 and adds to give me a positive 1? Well, this is going to be the limit as x approaches 1 of 2 times x minus 1 times x plus 1. And that's all over x minus 1. I was able to have my denominator cancel out, so my equivalent limit is the limit as x approaches 1 of 2 times x plus 1. And this is equivalent for all values where x does not equal 1. So now I can do direct substitution and plug 1 in for x. So I'll get 2 times 1 plus 1, which equals 2 times 2, which equals 4. So 4 is the slope of my tangent line, which is my instantaneous rate of change. So my average rate of change is 5, and my instant rate of change is 4 in number 1. And let's quickly graph that tangent line so you can see. Now the tangent line is a line that intersects a curve at a given point, and it does not intersect the curve again in that area. So it just touches the point and continues on. And remember, we're looking at that leftmost point, so when a is equal to 1, and there is our tangent line. Let's continue on to the next problem. So we're finding the average rate of change over the interval from 0 to 1/2. So doing some preparatory work, let's calculate f of x and f of a. A is 0 and x is equal to 1/2. So f of x equals f of 1/2, which is negative 1 over 1/2 minus 3. So that will give us negative 1 over 1/2 minus 3 is going to be negative 2.5 or negative 5/2. So if we have a negative over a negative, that's going to be a positive. So we'll have 1 over 5/2, which dividing by a fraction is the same as multiplying by the reciprocal, and 1 will get multiplied to 2/5 to give us that f of x is 2/5. Now let's calculate f of a. F of a is the function evaluated at 0, so that's going to be negative 1 over 0 minus 3, which is negative 1 over negative 3, which is a positive 1/3. Now let's find the slope of that secant line, which is f of x minus f of a, so that's 2/5 minus 1/3 all over x minus a, 1/2 minus 0. 2/5 minus 1/3, writing that in order to combine those terms, that's going to be 6/15 minus 5/15. And that's all over 1/2 minus 0, which is 1/2. 6/15 minus 5/15 is 1/15, and that's divided by 1/2, which is the same as multiplying by 2. So 1/15 times 2 over 1 equals 2/15. So the slope of my secant line is 2/15. That is the average rate of change. Now I'm going to find the slope of my tangent line to get my instantaneous rate of change, which is the limit as x approaches a of f of x minus f of a all over x minus a. So this is going to be the limit as x approaches a, which that's going to be as x approaches 0 of f of x, which we know is negative 1 over x minus 3, minus f of a, which f of a we calculated to be 1/3, all over x minus a, x minus 0. So you can see that if we were to plug 0 in for x, we would get 0 in the denominator. So we're going to have to simplify in order to solve. So we'll have the limit as x approaches 0 of, I want the fractions in my numerators to have a common denominator so I can subtract or add them together. So I'm going to need to multiply my first numerator by 3 over 3. That's the denominator of my second fraction. So 3 over 3 times negative 1 over x minus 3. And I'm going to be subtracting my 1/3 times that denominator of my first fraction over itself. So 1/3 times x minus 3 over x minus 3. And remember, this is all over x minus 0. So now I'll have the limit as x approaches 0 of 3 times 1 is 3, and that's going to be 3 times x minus 3. And I'll be subtracting x minus 3 over 3 times x minus 3. And again, this is all over x minus 0. So now I can combine my numerators within my numerator. And quickly, this 3 over 3 times x minus 3, I forgot my negative. So make sure we have that in because 3 times negative 1 is negative 3. So now that I've got that numerator correct, I'll go ahead and simplify. So the limit as x approaches 0 of negative 3 minus a negative 3 is negative 3 plus 3, which is 0, and then we're subtracting x. So I'll have negative x over 3 times x minus 3, and that's all over x minus 0. But x minus 0 is simply x. So now you can see that when we take the limit as x approaches 0 of negative x over 3 times x minus 3, if I'm dividing by x, that's the same as multiplying by 1 over x. So you can see that my x's will cancel out. And that's going to give me the limit as x approaches 0 of negative 1 over 3 times x minus 3. So all I need to do now is direct substitution and plug in my 0 for x. So I'll have negative 1 all over 3 times 0 minus 3, which is negative 1 all over 3 times negative 3, which is negative 1 over negative 9, which is a positive 1/9. So my instant rate of change is 1/9. Let's continue on to the last two problems on this worksheet. It says for each problem, we're going to find the equation of the secant line that intersects the given points on the function, and we're also going to find the equation of the tangent line at that leftmost point, so at A. And we're going to sketch both lines for comparison. Now in 3 and 4, I want to introduce the same formulas we've been using, but in a different way. But if you're confused with this new definition, remember that the slope of the secant line is the average rate of change and the slope of the tangent line is the instant rate of change. So once we find those slopes, in order to find the lines, we need to plug an x1 and y1 with that respective slope in for point slope form in order to solve for the equations. So again, you find slope and then use the appropriate coordinates to find the equation with point slope form. But let me introduce you to the second definition. So the slope of our secant line, we usually write as f of x minus f of a all over x minus a, the change in y over the change in x. But let's say that we're writing it in terms of that change in x. And let's make that value h. So h is the change in x. So now my interval is going to go from a to a plus h. And again, delta x, or the change in x, is h, because originally we were taking x minus a, but look, if we have a plus h and we're subtracting a, that's going to equal h. So now we're using the interval from a to a plus h just so that it's in terms of delta x. And we're going to adjust the top of our function as well. So as opposed to having f of x minus f of a, we're now going to have f of a plus h, because f of x plus a was our f of x, and we're still subtracting f of a. So you can see the formula hasn't changed in what it's doing. It's taking the function value of the end of our interval and subtracting the function value at the start of our interval and dividing it by that change in x. So delta y over delta x. Change in y over change in x. So with this, that means that when we're finding the slope of the tangent line, it's going to be the limit of, as opposed to x approaching a, it's going to be the limit as h approaches 0. So as this change of x gets closer and closer to 0, that helps us find that tangent line, which is why using this definition makes a little more sense, because originally we were taking our x, and as x approached a, we were making that x smaller and smaller and smaller until it was almost equal to a, which when subtracted would be closer and closer to 0. So now it's the limit as h approaches 0 of f of a plus h minus f of a all over h. But if you don't feel comfortable using this yet, go back to the previous definitions that we used for numbers 1 and 2. Although this definition directly relates to the derivative. And the derivative is the slope of the tangent line, but over the course of many values. So we could pick any point and find that slope by plugging that x value into the derivative. But we'll learn about that in the next video. So let's continue on with number 3. Now, because we're given the points, we're given a and f of a, and we're given a plus h and f of a plus h. So finding the secant slope is going to be easy. F of a plus h is 7/4. So for the secant, we're going to have 7/4 minus f of a, which is 2, and that's going to be all over h, which h is simply a plus h minus a. So calculating that quickly, a plus h minus a equals h. So -1/2 minus a minus -1, or plus a +1, equals h of a +1/2. So the change in x interval is 1/2. So h is our 1/2. And you can see that from -1 to -1/2, 7/4, that is a half step in the x direction. So h is 1/2. Now simplifying, we'll have 7/4 minus 2 in terms of 4, that will be 8/4 all over 1/2, which 7 minus 8 is a -1, so I'll have -1/4 divided by 1/2, which equals a -1/4 times 2 over 1, which simplifies to -1/2. So the slope of our secant line is -1/2. Now I'm going to use point slope form to figure out the equation. Y minus y1 equals m times x minus x1. So y minus y1 I'm going to use a and f of a as x1 and y1. So y minus y1 is y minus 2, and that's going to be equal to the slope of negative 1/2 times x minus x1, which x1 is a negative 1, so as opposed to subtracting negative 1, I'll add a positive 1. Now I'll need to distribute that negative 1/2 to the x and to the 1. So we'll have y minus 2 equal to negative 1/2 x plus negative 1/2. And now I'm going to be adding 2 to both sides in order to isolate that y. So y equals negative 1/2 x plus negative 1/2 plus 2 is a positive 3/2. So y equals negative 1/2 x plus 3/2 is the equation for my secant line. So now I'm going to clean up some of this work and get ready to calculate my tangent line. So quickly writing my secant line at the bottom so that we don't forget. That was y equals negative 1/2 x plus 3/2. Now to find that tangent line slope. So I have the limit as h approaches 0 of, let's calculate f of a plus h. If a is equal to negative 1, that's going to be negative 1 plus h squared plus negative 1 plus h plus 2. So this is f of a plus h, where a is negative 1. And then I'm subtracting f of a, which is a positive 2. And that's all over h. So again, I have to leave my variable as h because that's what we're calculating for. We're trying to see at this point a, what is the slope of our tangent line. So the h is going closer and closer to 0. So now to simplify, you can see that 2 cancels out with 2 in the numerator. So I'll have the limit as h approaches 0 of negative 1 plus h squared. I'm going to FOIL that out. So that's going to be negative 1 plus h times negative 1 plus h. Negative 1 times negative 1 is a positive 1, plus negative 1 times h plus negative 1 times h is going to be negative 2 times h, and I'm going to be adding that to h times h, which is h squared. So again, what I just did, I did negative 1 plus h times negative 1 plus h, and then FOILed that out. First, outside, inside, last. So if you need to write that out, feel free to do so. Then I'm going to add a negative 1 and add h. And this is all over h. So now I can simplify my numerator even further. 1 minus 1 will equal 0. And I have negative 2h plus h. So that's going to be a negative h. So the limit as h approaches 0 of negative h plus h squared all over h. Now in order to simplify, I'm going to break this limit up because I have a common denominator. So I'll have the limit as h approaches 0 of negative h over h, and I'll be adding that to the limit as h approaches 0 of h squared over h. So that's going to be the limit as h approaches 0 of negative h over h is a negative 1. So I have the limit of negative 1 as h approaches 0 plus the limit of h squared over h is a positive h as h approaches 0. So as h approaches 0, the second limit will become 0. So I'm left with the limit of negative 1 as h approaches 0, which is equal to negative 1. So the slope of my tangent line is negative 1. So again, the slope of my tangent line equals negative 1. Now I'm going to use point slope form and plug that in. But it's very important to note that we're finding the tangent line at point A. So x1, y1 cannot be a plus h and f of a plus h because that point does not fall on the line. I have to use a and f of a as x1, y1. So I have y minus y1, which is 2. That's going to equal the slope, -1 times x minus x1, which is x minus -1 or x plus 1. So I'll have y minus 2 equal, distributing my -1 to the x and 1, that's going to be negative x plus a -1. Now all I need to do is add 2 to both sides and simplify in order to isolate my y. So y equals negative x plus 1. So the equation for my tangent line is y equals negative x plus 1. And so you can see each of these, I'll go ahead and graph. So our secant line, remember, is the line that intersects the given points, which was -1, 2, and -1/2, 7/4. And the equation for my tangent line was the line that intersected my point where x is equal to a, which is -1, and it intersects only at that point. So there you can see my secant line and my tangent line graphed. Let's move on to the last problem, number 4. So looking at number 4, we're given a, f of a as -1, 1, and a plus h, f of a plus h as -1/2, 2/3. Now before we get started, let's find what h is equal to. Remember, a plus h minus a equals h. So a plus h is -1/2, and I'm going to be subtracting a, which is subtracting a -1, which is the same as adding a +1, and that's going to equal my h value, which is a +1/2. So 1/2 is h for number 4. Now let's find the slope of that secant line. So I'm going to have f of a plus h minus f of a all over h. F of a plus h is 2/3, and I'm subtracting f of a, which is 1, and that's all over 1/2. 2/3 minus 1 is going to be a -1/3, so I'll have -1/3 over 1/2, but dividing by 1/2 is the same as multiplying by 2. So -1/3 times 2 is a -2/3. So -2/3 is the slope of my secant line. Now I'll use point slope form to solve for that equation. So I'll have y minus y1, which I can use a f of a or a plus h f of a plus h, because both fall on that secant line. But I'll go ahead and use a f of a because the numbers are a little easier to manipulate. So y minus y1 is y minus 1, and that's going to equal the slope of -2/3 times x minus x1, which is x minus a -1 or plus a +1. So distributing -2/3, I'll have -2/3 x plus -2/3. Then all I need to do is add 1 to both sides in order to isolate my y, so I'll get that y is equal to -2/3 x plus -2/3 plus 1 is a +1/3. So -2/3 x plus 1/3 is the equation for my secant line. While I'm at it, I'll go ahead and graph that. So at -1, 1, and -1/2, 2/3, I'll draw my secant line. Now let's calculate the slope of our tangent line. That's going to be the limit as h approaches 0 of f of a plus h, where a is -1. So that's going to be 1 over -1 plus h plus 2, and I'm subtracting f of a, which is 1, and that's all over h. So simplifying, the limit as h approaches 0 is going to be 1 over negative 1 plus h plus 2 is going to be a positive 1 plus h, and I'm subtracting 1 from that, and that's all over h. Now, in order to combine the terms in my numerator, I'm going to put them over a common denominator. So I'll have the limit as h approaches 0 of 1 over 1 plus h minus 1 plus h over 1 plus h, because 1 plus h divided by 1 plus h is 1, and that 1 was subtracted. And remember, this is all over h. So that's going to be the limit as h approaches 0 of 1 minus 1 plus h. You can see that my 1's will cancel out, and I'll be left with subtracting h, so that's going to be negative h over 1 plus h all over h. Now I'm going to write this, as opposed to dividing by h, I'm going to write it as multiplying by 1 over h, so you can see that my h's will cancel out. So I'll have the limit as h approaches 0 of negative h over 1 plus h times 1 over h. Negative h divided by h is a negative 1. So I'll have the limit as h approaches 0 of negative 1 over 1 plus h. And this limit is equivalent to my original limit for all values where h is not equal to 0. But what this allows me to do is plug in 0 for h. So I'll take negative 1 over 1 plus 0, which is going to give me a negative 1. So my slope for my tangent line is negative 1. Now I'll use point slope form, making sure to use x1, y1 as a, f of a, because that is the only point that this line will intersect. So y minus y1 is y minus 1, and that's going to equal my slope m of negative 1 times x minus x1, which will be x plus 1. So I'll have y minus 1 equal to negative x minus 1, and then I'll add 1 to both sides in order to isolate my y to get that y equals negative x plus 0. So my tangent equation is simply y equal to negative x. And this is going to be fairly easy to graph because my y-intercept, b, for this equation is 0. So it's going to intersect the point 0, 0. So when drawing my tangent line, I'm going to go through 0, 0 and intersect the point a, f of a. And that's my solution in number 4. If you had any questions at any point in this worksheet, please specify them in the comments below, and I or one of your peers will get back to you as soon as possible. If you found this video helpful, click that like button, and while you're at it, subscribe to my channel. Also, don't forget to share this if you know somebody else that will find this helpful or useful. And if you want more ways to support me, become a patron, click the link below to my Patreon page, or go to mainmap.com and explore around. Again, that's maemap.com.